Okay, in this video we're going to learn how to apply Ohm's law to electric circuits. So let's start off with a basic series circuit. Let's suppose that we are told that we have a 9-volt battery over here connected up to two resistors. Let's suppose this one is 2 ohms and this one is 3 ohms. So we want to know what is the current and voltage in each of these resistors. So to find current or voltage, we're going to use Ohm's law, V equals I times R. So we know the resistance of each of these, but we don't know either the current or the voltage. What we do know is that we can find the total resistance of this circuit. I know the total voltage, and I can find the total resistance because I know that in series circuits, I just add up all of the individual resistors to find the total resistance. So in this case, I have a total resistance of 5 ohms. And using Ohm's law, I can now take the total voltage divided by the total resistance to find the current. So my 9-volt battery is connected up to 5 ohms of resistance. That means my battery is able to supply 1.8 amps of current. And because this is a series circuit, that 1.8 amps is the same everywhere. Right? The current does not split up. It's 1.8 amps in every component. Now if I want to find the voltage in either of these resistors, I can find the voltage in the 2 ohm resistor, and I usually like to write down the value of the resistor so I know which resistor I'm calculating. So the 2 ohm resistor, I know there's 1.8 amps of current flowing through it, and it's 2 ohms of resistance. So I have a total voltage there of 3.6 volts. And in my 3 ohm resistor, again I have 1.8 amps in 3 ohms. So I end up with 5.4 volts. So I now know the voltage in each of these. I often like to write them as I've calculated them so I know which ones I've done and which ones I still have to do. What you should notice is that I have 9 volts of potential, and the potential that's dropped in each of these resistors. So the energy used up by this resistor is 3.6 volts. The same thing over here, 5.4 volts. That adds up to give me my 9 volts. Okay, so the total potential gains have to equal the total potential losses, right? Or the total potential dropped in the circuit. So if I have 9 volts here, I'm going to give up 9 volts as I go around the circuit. Okay, so that's a basic series circuit question, typical exam type question. Okay, let's take a look at a parallel circuit. Let's stick with our 2 ohm resistor and our 3 ohm resistor and our 9-volt battery, but now they're connected in parallel. So to find the total resistance, I have 1 over 2 plus 1 over 3. They have a combined resistance of only 1.2 ohms. So when I find my total current, I take my 9 volts, divide by 1.2 ohms, and I find that I have 7.5 amps of current flowing through this circuit. Okay, so again, 7.5 amps being produced by the battery. That won't be the current down each path though, because down each path I'm going to have a different amount of current. So how am I going to find the current in these two resistors if I don't know the voltage? Well, another thing to remember about parallel circuits is that the current gains 9 volts in the battery. So it's going to gain 9 volts here, it's going to travel around the circuit, and if it takes this path, the only resistor it passes through is this resistor. So the 9 volts of energy potential that it has is the 9 volts that it loses in this resistor. So the voltage here is 9 volts. Same thing over here. It will also be 9 volts. So in a series circuit, the current is always the same everywhere in the circuit. It's the same current. But because the current splits up, in a parallel path, it's the voltage that's the same in each path. So now that I know the voltage in each of these resistors, I can find the current. So the current over here is going to be 9 divided by 2. So I get 4.5 amps of current in this resistor. And over on this side, I get 9 divided by 3. So I'm going to get 3 amps of current on this side. So I have 4.5 amps, 3 amps, and again the total adds up to be 7.5. Okay. Again, the key thing to remember, in a parallel path, two resistors connected in parallel have the same voltage. Okay? All right, let's try one more, slightly different. This time, let's say that we're told that the current in the first resistor is, let's say, let's say we're told the voltage here is 2 volts. And we want to know what is the voltage of this battery. Okay, so slightly different question. We're changing the unknown. We don't know what the battery is. Always start a question wherever you know the most information. In this case, I know 2 pieces of information about this resistor. So I could start here. I could also start by calculating the total resistance. Right? So I know the total resistance is 5 plus 10 is 15 ohms. Sorry, this is resistance. Total resistance is 15 ohms. But that doesn't help me because I still don't know the current. But I can find the current here. I know the current in this resistor is going to be 2 volts divided by 10 ohms. So the current is 0.20 amps. So now I can find the voltage of the battery because I know it's going to be the current times the resistance. So I get a total voltage of 3 volts. Okay. Each question, though, all you're doing is applying Ohm's law to each individual component or to the entire circuit, and also applying what you know of series and parallel paths. So in this case, because I know this is a series circuit, I know that the current over here has to be the same as the current over here. If it was a parallel path, I would know that the voltage is the same in each path. Okay, so that's some simple examples of using Ohm's law. There's more examples in the textbook and lots of practice questions for you to try.